Hi, this session is called Analyzing Revit Data Using Microsoft Power BI. If you're using Revit, then you need to do model health checks of your Revit models periodically to make sure they're running correctly and also they're also performing the way they should perform. In this presentation, we're going to go through the process of extracting data from Revit, health check data, using ID8 BIMlink into an Excel file, and then we're going to use that information in Microsoft Power BI to analyze and to look at the data. My name is Dan Tartaglia. I've worked in the AEC industry since 1986. I've been working at MBBJ for 15 years. I'm an expert at Revit and the Revit API, along with Microsoft Power BI. And my job is really to do my best at helping our teams be successful. So if it's to create a Revit add-in, or if it's to do training, support, research new tools, do new processes, that's my job. MBBJ is an architectural design firm, and we have 11 offices around the world. So learning objectives are to know what ID8 BIMlink and Power BI are used for. Learn where to find resources for BIMlink and Power BI. Learn how to extract data from a Revit model using ID8 BIMlink and bring into Power BI. Create and walk through an example of actually creating a health check Microsoft Power BI report of the data. So what is ID8 BIMlink? ID8 BIMlink is a tool that in Revit allows you to export data from Revit to Excel, modify the data in Excel, and then import it back into Revit. We use this tool a lot at our firm, and it's very useful to modify room data, to change family names, family type names, to be consistent with project or firm standards. See the link for more information, but it's a great tool to use. Microsoft Power BI is a tool that allows you to bring in data and then visualize it and manipulate it in different ways so that you can actually look for any problems, you can identify any issues, and it allows you to make informed decisions. We're also going to be using something called ID8 Explorer, and just very briefly, just for the manual process of this, and this is because ID8 Explorer can get us Revit warnings, which we can't do otherwise. And for a health check, you need to have Revit warnings. That's just a fact of life. It's a great tool as well for other purposes, and if you want more information, the link is below and also in the handout. This is the process we're going to go through today. First one's going to be manual quickly, and then we're going to do an automation process so that you can see how much better it is. But the basic idea here is that from ID8 BIMlink, we're going to export from Revit health check information. And then from ID8 Explorer, all the warnings. After that, that information will all be put into an Excel spreadsheet that we're going to use in Microsoft Power BI to analyze the data and see how well the model is actually performing. So how to extract data using ID8 BIMlink and Explorer, this is the manual process. So the first step is really going to be to copy the Excel template file from ID8's folder structure. So we need to go open up Windows Explorer, and we need to go into the right version of Revit, by the way. So right now I'm using Revit 2020, so I'm going to go into the ID8 Software 2020 folder, the ID8 BIMlink folder, the US folder, samples, and then I'm going to go into health check. And notice at the bottom there's an Excel spreadsheet. That's the template file. We need to copy this file into a project folder so that where we're going to do our health check in. So let's copy this file. And we'll put it in this folder for now. After that part's finished, we're next going to go into Revit. And then we're going to go into the ID8 tab, ID8 software, and then BIMlink. Again, this is the manual process. So click on the new button there. And under folders, select Health Check. And then shift select all those HD link files. And then hit Next. Now, from this point, you have to pick one file at a time. So we're first going to pick the dimensions file there and hit Export. So that's going to export the data from Revit. And then we're going to pick the Excel file we copied, that template file, and put the information in there. So we're going to hit Save. So now it's going to grab the file information. Well, it's going to ask it to overwrite the Excel file first. Then it's going to extract the information from Revit and save it to that Excel file. Now, this is the manual process, as I said. I wouldn't necessarily do this for a lot of files because it takes a long time. So we have to do it for each one of these 10 HC- files, which would take a long time if you did this in the real world. Each time you got to pick that template file to save the data into it. There's two of these HC files take longer than others. Typically, one is HC-ID8 and the other is HC-Views, a little bit down further. There it is. But once you do all that, you have that Excel file. Once you finish that process, you have that Excel file, and then you can use that in Power BI. We're not finished yet then, so. Next, you have to go to the ID8 Explorer to get the warnings. And again, it's something we're just doing in the manual process, and I wouldn't expect you to do this manual process very often, to be honest. So first thing to do is click on the Warnings tab there out of those three tabs. You can see all the Revit warnings. Aren't that many in this file, but then you click on this View Warnings button, and you'll see all the warnings, and hit Export. And not many warnings. And then you just pick the same Excel file, and then all that information is in one location that we can use in Power BI. That is the manual process of doing this. And it's not my recommended way of doing it because it would just take a long time on a typical basis. So next, we're going to go through the automated way of doing it. So let's cancel out of here. So we're going to watch the video, and that goes to the automation part of it because it'll take a little longer, and I'm going to speed it up a little bit. So that's the tool right there that you can get from ID8 that can automate this whole process. The first step to this process, though, is actually to open up Revit. And you need to sync the file because this is actually a BIM 360 model, and we need a local cache file for this to actually work in a BIM 360 model. So after we sync this model, we can close Revit. Now we're going to launch the ID8 automation tool. And a dialog box will open. We'll click Add Task. Now we need to pick a script file, and because right now it's in beta, so it's in a separate folder, but it's going to be in this folder very soon. So let's go into this Browse button here, and we'll just pick this file here under beta. And it's going to do exactly the same thing, even copy the template file for us. So once we pick the file and we hit Open, next we need to fill in some of these fields to make sure they're filled in. First is pick a Revit file. So we'll hit Browse, and I'm going to pick Cloud Models and Retrieve File Data. Next, it's going to take a second for it to load, but there it is. We'll pick our file, and then we'll pick Select File. Under Export Template File, that needs to stay the way it is. And then under export folder, we need to specify where we're going to save this Excel file to that has all the Revit data in it. And we're going to use the same folder. So I'm going to go over here and just get this path. And I'm going to put that in there. Under export file, we'll keep the same name. It'll actually append today's date as well to that name. And then here we need to put what version of Revit we're actually using. So right now it's trying to use ID8 software 2021. So we need to change that for my case to Revit 2020. So I'm going to change that 2021 to 2020. And then at the very bottom here, if you want to use the Windows Task Scheduler to automate this once a week, let's say, this information can allow you to do that. You can automate this process once a week, once a day, whenever you want to. But when you're finished this process here, you click on Create and Run. What's going to happen is it's going to create a log file, and then it's going to launch Revit. A side note being that right now, this version handles one file at a time, but when it's fully released to the public, it's going to let you pick multiple files to process at the same time, not just one. So it's launching Revit right now. First thing it's going to do is it's going to export all the warnings while the file is opening. Once the file opens, it should start processing all those HD link files that we did manually a few minutes ago. So it's doing exactly the same thing we did manually, but it's doing it in an automatic process, automated process. And with the task scheduler, it's even more automated. You can just do it once a week and not have to worry about it as long as your computer is on. I'll probably speed up this process a little bit. When it finishes, it'll close Revit, and you'll see the log file here, and it'll show you if any errors were found, and also tell you how long it took to take. In this case, it took 5 minutes and 17 seconds, but a larger file would take a lot longer. We'll just close this. And let's go back into Windows Explorer. What we're going to do is we're going to actually look at the that output version of that file so that you can see what's in it in Excel. So there are a lot of tabs here, and the first colored tabs you're seeing, those lighter colored tabs are coming from ID8, and that's really a help tech in itself. There's a bunch of pivot tables. And so they might be very useful in themselves. But after that, you'll see all these HC-blue tabs. That's all the raw data coming from Revit. And it's a small file that I processed here so that it would go fast. And at the very end it's actually the warning data that came from the model. That's really what's in this Excel file in the end. How to visualize the data in Microsoft Power BI now. So in Power BI, what we're going to do is we're going to open up a Windows Explorer window again. And we're going to copy an existing one that I have already exported that's much bigger. It's 25 megs. And we'll copy that into that project reports folder so we have that to use instead. I think this model is 1.6 gigs that came from this file here. If we open up this file here, I want to show you something. Every Revit model has different Revit warnings in it, as you probably know. And every Revit warning may have different number of elements that are assigned to it, different number of columns of Revit elements. in the warnings. So if I go down to the warnings, detail warnings, right there, this model only has 3 columns of warnings for any of these elements. Yours might have 100, so it really depends on the model. But for the Power BI file to work correctly, there has to be at least 15 element columns. Again, yours might have over 100. This one happens to only have 3, which might be unusual. But I wanted to show you this just in case you come across it. So what I'm going to do right now is put 15 element columns in here so that Power BI is okay with it. Power BI can be rigid in how it handles data, and this is definitely one part that is a little bit rigid. So once I add those 15 blank columns, I'm just going to close and save this file. Okay, so next we're going to actually go into the Power BI template file so that we can create our report. So let's go back into the class files folder, and then you'll see the health check template.pibt, which is Power BI template. Double click on that and Power BI will launch. And then in a second, you'll see a field for a parameter, just like you would see in Revit. So it's looking for where that Excel file is. So what we're going to do is we're going to go back to Windows Explorer. And then there's a little trick to get the full path to the file name, full path of the file. If you shift right click on a file, you can get the full path into the Windows clipboard. So if I shift right click, I can go down to copy as path and get the whole path to that file. Go back into Power BI and then put it in there. And get rid of the quote at the back and at the front of the string as well. And then I'll hit load. Now it's going to load all the data into Power BI. We're not done yet. There's another step to this for the first page, the summary page. And it's not a hard thing to do, but something needs to be done to make sure the data is correct. So right now let's wait until it loads. There are 2 main visuals here, model health and model score. There needs to be 12 metrics in that model health table you're seeing on the left. Right now there's only 11 because I'll show you why, but we need to fix that. So what we're going to do is we're going to actually go into the Home tab and then the Transform Data button here in Power BI. And that's going to show us all the data that's actually available in Power BI. And there's 12 tables in here. We need to make sure to have 1 row each, starting with underscore design options all the way down to underscore work steps. So if I look at underscore design options, you notice there's three columns with 1 row. The first column is the design options that are in the model. The second column are recommended by your company, and the fourth is the score value for that gauge. But you see that first design options has a value, which is good. So next we need to go look at duplicate families. And then you keep going down those tables real quick. Second one has no row at all in this one. So it has to have 1 row. So to handle that, if you look in the very bottom left of all the tables, there's a lot of blank tables. And there's one called underscore duplicate families blank. So what we have to do is we have to go to append queries. And we need to scroll down and then select that underscore duplicate families blank table. And hit OK. So it has 1 row. That's all we needed. I happen to know the rest of these have a value. So you'll see there are 27 imports. There are 30 in-place families, the big model. To see all the data that's in these different tables as I go through them, all the warnings, and then the work steps. The magic table in this whole thing is metrics, because metrics is really almost a match for what you're seeing there. If I click on the metrics here, metrics table. You'll see a column, a row for each one of the 12 metrics that I mentioned. And you'll see the value from Revit. You'll see the recommended value from your firm. The score that would be assigned to the gauge, depending if the metric failed, if it was a bad score, and then the actual score that we're going to be using in the gauge, that gauge visual. So that's kind of where this is kind of working from. So once you have those 12 values in there, that's the important thing at first. So at this point, I can hit close and apply, and it's going to update my Power BI report. And once it finishes spinning, you'll see that you'll have 12 metrics on that table. The gauge won't change because the metric we changed isn't going to affect it. And there are 12 values in that model help table. What if you want to change one of the, well, first we'll save the file. That makes more sense. And then let's save the file to the same folder as we have the spreadsheet and with the same name. Just so we don't lose our information here, our data. Okay, so next thing is, what if you want to change one of those recommended values? What if you want, your firm wants only recommended 10 work stats instead of 30? Those recommended values can be changed. So let's change that so you see how it's done. So I'm going to go to the transform data button again, and I'm going to go down to underscore work stats table, that's on the left-hand side. And then you'll see the information there. There's 15 work sets, 30 recommended. So I'm going to change that 30. So what I'm going to do is I'm going to pick on the add custom applied step here. You'll see right here. And you can change it in two ways, with that gear right there or with this actual formula. But I'll choose the gear. And it'll show me the information. And all I have to do is change this 30 to a 10. That's really all you have to do. Once I hit OK, that'll change, and then I'll click close and apply. So now I have 15 work sets in the model, and I'm changing recommended to 10, which means my gauge will probably change because my score will be lower. I have too many work sets. That's how you change the recommended values. Let me go back to transform data one more time to show you one other thing and go back to the metrics table. There's one important thing I wanted to show you, and that is if you change the, once I let it load first here, take a second to load the table. If you change anything in that score column, the scores add up to 100. That's how the gauge works correctly. If you make it less or more than 100, that gauge won't be correct. So that's the idea behind that score column. So if you change any of those values for priority, just make sure they equal 100 in the end. And that's it for that particular gauge and those metrics right there. So other than that, if I look at this first page here, you can see that all the metrics are there. There's a score. I can sort this in different ways. Notice the red and green circles, which means that they passed or failed the metric. I can sort that as well. So I can only see the red ones at the top and which ones failed. There's a lot of things you can do in here. All this data is coming from the Excel file, except for that bottom right-hand corner tab right there. That's actually the actual data I ran the report. Now the warnings tab, these are all the warnings. If I click on, let's say, the low bar, that yellow low bar, and I click on, let's say, I want to see my highlighted floors that overlap. There's three warnings for that one. Now I can see all the floors and who created them, and also all the element IDs. And to me, the element IDs are the most important thing. That way you can change them, and you can change the error in Revit and then fix those warnings. Next one is the families by work set. And this tab here shows that, well, we have all these work sets, and why does one work set is so much bigger than the rest of them? There might be a good reason for that. Maybe balance-wise, it wasn't done correctly. It has to be looked at. So it's an indication that it possibly a red flag. But if I click on it, you can see all the elements that are actually in that work set, and also how many, and their element IDs. And if I click on, let's say, this link work set here, that's a common name we have for our links. For some reason, if I click on that one there are 3 basic walls in that work set, which really shouldn't be. But I have the element IDs right there, and I can fix that, or have the MEP fix it. There's a lot of information in here to look at under families by category and work set. I can sort it in many ways by picking those buttons. If I click on walls, I can see all the walls in the whole model, for example. They're all in that one work set. So that's it for this particular one here. If I go to the next tab here, it'll go into families by phase and category. So if I click on the very top left-hand button that has no value, that means that those objects are not in a phase at all. So all those walls and ceiling have no phase value, and there's 18 of them. So I can click on any one of those, and there are filters. So I'm just filtering out which elements I want to see. So what I'll do right now is I'll get rid of that filter by clicking, let me see here, by clicking that news instruction, and then I can see all the families there. And next is the model line rooms, the model lines by room, I should say. So these are all the model lines by room. The model lines are typically bad. If I filter it by a floor, let's say floor 2, I can see all the model lines that are in each room. And you really should probably switch them to detail lines unless there's a good reason. I pick a room like pharmacy, you can see there's 50. You can see who created them. You can see a lot of information about the model line type, who created them, and also the element IDs. Again, it's very important, the element IDs, so you can find those objects in Revit. View information will show you information about why maybe the views are not performing very quickly, why your model might be slow. So notice there's a green, orange, and red stoplight sort of thing. Also, right now it just shows all the views on the sheet. But you can see all the red circles. Red means that they're not cropped views, which can cause a lot of slowness. You do want to choose a good view type. Now there's only 2 that are shown under plan views. But there's still probably ones that could be corrected. They should have crop views so that they perform faster. So you can sort this in that way. You can also click on those 3 buttons there. I'm going to see just the orange ones, which mean the detail level of the view is fine, which also could be a slowness issue. Green means they're perfectly good. There should be no issues at all. You can determine if it has a template or not. You can see the percentage of views not on sheets. 38.4 is pretty good. Total number in selected. And you can do it by view type. So there's so many ways to filter. So under import information, these are all your imported objects. In this case, all the imported objects are in drafting views. You would see other view types there if there are other view types. So if I pick on, let's say, partition and mullion cap types, I can see all the imports that are in that particular view. And you also see who created it, that view, and also updated, and on the element ID, of those imports, not the view, the imports. The last tab here is dimension override information. So these are dimensions that were overwritten on purpose by a user. So Revit didn't have them as correct dimensions. They're actually now modified. So if I choose floor plan, for example, right, that's the standard toilet floor plan. So that might be okay that they overwritten it to be a foot. Maybe it was on purpose. And the element ID is there, as you can see as well. But let's say I chose elevation, which are live views, and I scroll down a little bit, or if I choose a particular one here. Let's scroll down a little bit. You'll see there's a couple that are actual numbers on the gift shop. Why on the gift shop they're hard coded to those values and not using Revit is a question mark. So that's an indicator. So something to look at. Thank you for attending this session. I really appreciate it.